Hello everyone, today we're going to be balancing redox reactions. I'm going to split this into two lessons. Today we're going to focus on acidic, and then in the next lesson we're going to focus on basic conditions. Let's recap what exactly are half reactions and how do we write them. We need to understand how to write half reactions because this is going to be step number one in balancing redox. Typically, for half reactions, you are given the net ionic equation with anything not involved in the reaction being crossed out. Here, we're going to see that I need to write two half reactions. Manganese is going to be with my manganese over here, and carbon and oxygen is going to be here with my carbon dioxide. For the steps for balancing half reactions, we need to first balance the atoms, and then we can balance the charges. So to balance the atoms first, typically you're going to use coefficients in front of the numbers. However, sometimes there's difficulty balancing oxygen and hydrogen, so we tend to use water and hydrogen H plus ions. The reason for this is because typically these take place in aqueous solutions where they are diluted in water, so you're going to see water and hydrogen ions. Next, once you balance them, you're going to balance the charges using electrons. Now, I had you guys add this to your notes, but typically you're going to add electrons to the most positive side. The reason for this is because we want both sides' charges to be balanced, and electrons can only bring positive sides down since they are negative. So we always add them to the most positive side and bring them down to the least positive. Now here again, we have our two half reactions, but we need to balance the atoms and electrons. Once we've balanced the atoms of electron using the rules that we learned in the last lesson, again, if you are confused on this, I always suggest that you come help ask or go back and rewatch that video. We're going to see that when we were balancing, manganese oxide here had 4 oxygen, so we added 4 water. Then we needed to balance our 8 hydrogen, so we added 8 plus 1 hydrogen ions. And then in order to balance the charge, we needed to add 5 electrons so that both sides equal positive 2. Down below, we needed to balance by adding a coefficient in front here and then adding 2 electrons to the right of this equation. Again, if you are struggling with those kinds of problems, please make sure that you ask because, like I said, step 1 is to write the half reactions for the given equation. Step 2, once you have the half reactions, we need to adjust the coefficients so that both of the half reactions have the same number of electrons. And typically we do this by multiplying the entire equation by some number. We want to make sure that the electrons lost equal the amount of electrons gained because of the law of energy and the law of conservation of mass. Once you do that, we're going to combine our half reactions by adding substances on the same side of the arrow and subtracting things that are on opposite sides of the arrow. And since we are learning that these take place in both acidic and basic conditions, let's remember what we learned in our acids and bases. Acids tend to increase your H plus concentration, while bases tend to increase your OH or hydroxide concentration. So if there are H plus ions in your balanced equation at the end, that is okay because that just tells me it's taking place in acidic conditions. Looking at that same example that we were working with half reactions, let's continue on with these steps that I introduced. First, we're going to adjust coefficients so that both sides have the same number of electrons. As you note here, the top reaction has 5 electrons and the bottom has 2 electrons. We want to make sure that we have one of the least common multiples. The closest number to both of these would be 10. So in order to get 10 electrons on the top, I'm going to take this entire equation up here and multiply it by 2. The 2 goes to everything. The bottom, what we're going to do is we're going to take this whole entire equation and multiply it by 5 and distribute that 5. When you distribute out, you get 10 electrons, 16 hydrogen ions, and so forth. Now that you have your electrons equal, here are my 10 electrons on my left, here are my 10 electrons on the right, we can go to step number 3. Step number 3 says combine half reactions. Again, to do this, we're going to add things on the same side, but subtract things on opposite. As we notice, those 10 electrons are on opposite sides of the arrow. Your electrons should always cancel. From there, you're going to notice that nothing else cancels. So in order to get this right, what we would redo is write everything together because it all adds. So we have 16 hydrogen ions, 2 MnO4 negative 1 plus 5 C2O4 2 negative yields 2 manganese plus 8 waters plus 10 carbon dioxide. Once you get here, this is exactly what I'm looking for the answer. You can always double check your charges to make sure that they equal one another, and you can also double check your atoms as well, but they should add. Let's try it with another example. Here we have a reaction and we need to write the two half reactions. Remember, chromium is going to be with chromium, and then iodine again is going to be with iodate over here. Let's first start with chromium. We have Cr2O7 with a 2 negative charge, and it is turning into chromium ion with a 3 plus. Let's balance our atoms first. Here we have 2 chromium, so to get chromium in here, I'm going to put 2 there. From there, we can see we have 7 oxygen, but none on the right. So to get 7 oxygen, I'm going to add 7 H2Os. This brings me in a predicament. I have 14 hydrogen, so I'm going to balance it out this side with 14 hydrogen. And the last thing we need to do is balance out these charges. Here I have 14 positive charges, minus 2 gives me 12 total on this side. This side we have a positive 3, but there's 2 of them, so it gives me a 6 positive on this side. So we have to figure out how many electrons are needed on this left side, since it's bigger, to drop down to 6. Well, 12 minus 6 gets me to 6, so 6 electrons is what's going to have to be used. From there, we can balance out the next half reaction. We have iodine yielding to iodate. First thing we should notice is that our iodine are balanced, but our oxygen are not. Here I have 3 oxygen on the right, so we're going to add 3 waters to balance those out on the left. However, I did introduce water, so I have 6 hydrogen here, so I need to add 6 hydrogen to the other side. See, I have a negative 1 over here, but over here we're going to see that it's a little bit different. I have a 6 minus 1 that gives me 5 over here. So I need to figure out what do I add to the right side to get from 5 down to negative 1. And if you add 6 electrons, it gets you down to that negative 1. After you do that, we can actually cross out things that are on both sides and combine like charges. Here, we're going to see that my 6 electrons already equal each other, so I don't need to balance those. They can just go ahead and cross out. Then what we can do is we see I have water on the left and water on the right, so I can simplify that. Here, I can get rid of these 3 oxygen. 7 minus 3 leaves me 4 water left. 4 water, not oxygen. And then I can also see I have hydrogen ions on both sides of the equation. So here I have 6 of them. They'll cancel. 14 minus 6 will leave me with 8 hydrogen over here. Once you get that all simplified, we can just go ahead and bring down and add together what's left. So I have 8 hydrogen ions plus chromium plus iodine yields 2 chromium ions plus iodate plus 4 water on this side. You can actually go back and check yourself on these, make sure that your charges cancel, make sure that your atoms add up correctly, but this should be your final answer. Last but not least, we do have example number 3. Here we have TeO3 2 negative reacting with dinitrogen tetraoxide, yielding tellurium and nitrate. We're going to split these into their two half reactions. So we have TeO3 negative becoming Te. Notice our tellurium are balanced, but our oxygen are not. So I'm going to add 3 waters on this side, but I have 6 hydrogen, but there's none over here. So I'm going to add 6 H plus over here. The other thing that we're going to need to balance is those charges. So here I have a positive 6, minus 2 gives me a 4. So I have a 4 charge over here on the left, 0 charge on the right. So I'm going to have to add 4 electrons over here. From there, we're going to balance the next one. We have N2O4. This is going to yield NO3 negative 1. First thing, we have 2 nitrogen here, so to balance out this nitrogen, I need to make sure that I put a 2 there. This brings me 6 oxygen on the right, but 4 oxygen on the left. So to bring this 4 oxygen up, I need to add 2 more oxygen in the form of water. This brings in 4 hydrogen, which I need to balance over here, 4 H plus. Once I do that, I need to balance my charges. So here I have a plus 4 and then 2 to the negative first. So 4 minus 2 gives me a positive 2 on the right. There's no charge on the left, so I need to add 2 electrons. Then what we can do is we can actually make sure that the electrons equal. Here this is 4 electrons, this is 2 electrons, so I'm going to multiply the entire bottom equation by 2. And when we actually do that, if we actually rewrite that, you get 4 H2O plus 2 N2O4 yields 4 NO3 negative 1 plus 8 hydrogen plus 4 electrons. So I'm going to actually go cross out this middle one since I don't want to confuse it. And we can actually combine these reactions and cancel. Note here my 4 electrons cancel. Here I have 6 hydrogen, and here I have 8, so 8 minus 6 leaves me 2 hydrogen left over. Here I have 4 water, and here I have 3 water, so my 3 water will cancel, and this will just become 1 water over here. And then what we do is we need to make sure that we bring everything down. So here we have TeO3 negative plus 2 dinitrogen. And then here we have also with water yields 4 NO3 negative 1 plus Te plus 2 H pluses left. And then again, if you double check the charge and you double check the amount of atoms, this should equal up. And that is how you do today's lesson. If you have any questions, please make sure you ask. And with that, I hope you guys have a great day.